We're now going to use Bentley Power Civil to do our drainage design for our site. Go ahead and access the Power Civil product. And this time we're going to open up a new design file where we'll lay out our drainage system. The drainage design process is basically you place your collection system, your inlets, and then your areas, and then you design your pipe system. So in Chapter 6 we have a file called siteplandrainage.dgn. We're going to access that file to place our drainage structures and our drainage areas and so forth. To access drainage from the Power Civil menu, you just go to Civil Drainage. There's also an icon located on the Power Civil tools. Once we access drainage pull-down menu appears in the main menu, and we can open a project, create a new project. We have access to the various components of drainage, again the nodes, the areas, the pipes or links, create profiles once we have our pipe system, do culvert design and routing. So the first thing I'm going to do is create a project or open an existing project. So we've got a existing project that was already created for this exercise. I'm going to use that one. So I'll see project open, and it's called siteplan_drainage.gdf, geopack drainage file, and that's located in Chapter 6. So I'll open up that project, and basically it's a blank project. It just has some project preferences that have already been kind of set up for us. Let's take a look at those preferences under the drainage pull-down menu, project preferences, and we'll just quickly review those. Our project is in English. We have some unit descriptions here, so intensity would be entered in inches per hour, velocity will be feet per second, and so forth. Project components, we're accessing a drainage library file, standard library file where all our possible inlets and pipes that we'll use for this project and all projects are stored. We have a GPK file that we've been accessing through the site modeler, and we'll access the same one here. And we have a cell library that corresponds with our drainage library, and it has all the graphical cell representations of our inlets. We're also accessing our standard site.ddb file, and we're accessing our site project with our original ground surface being ground 1 and our design surface being the model or tower. Our rainfall parameters, based on the drainage library that we're using, we've got several rainfall sources with the rain intensity data stored in them, and we're choosing zone 1. If we run the SCS method, then we'll use type 1. In our case, we're going to be running the rational method for our drainage areas. Land use, we've got it set up to use private land use, which means that Geopack will be able to automatically calculate the composite C value for our various drainage areas based on Geopack shapes that we've drawn in the file that represent the various land uses. And for example, I've drawn a few shapes in there. That represents grass area. Here this represents pavement. This shape represents pavement as well. So I don't have to know the coefficient for pavement or grass. It's going to automatically pick up the shape, and that shape has a coefficient associated with it. Frequency options, we're going to run it for a 2-year storm event or a 2-foot depth if we run SCS. Again, I can come back and change these preferences if I want to change it to a 5 or 10 or 50-year storm event. I can come back to the preferences, change that, and recompute my drainage system. Intensity options, I've set that to compute the intensity from the library rainfall data source, so it'll use our drainage library and grab the appropriate intensity from there. And I've set up a minimum time of concentration of 10 minutes. Junction losses, I've disabled those for now, but if I I may disable them if I want, or you can leave them, and the various coefficients. Inlet options, right now I've got my inlet option set to handle bypass flow. So if I have bypass flow, it's going to bypass it as total discharge. And my link bypass flow options, I am not going to allow the inlet bypass to be used in the link discharge calculations. Node options, I've created a standard naming convention for my nodes, CB-. Set a minimum freeboard if you want. Link options, the same thing. I've set a standard naming convention of SS-. And for my design, I'm going to minimize the depth of cover when I design it. And I'm going to design for maximum capacity. Profile options, I've set no profile options for now, but we could set up a default naming ID for profiles, and we also store our profiles into our coordinate geometry database if we want. As far as the plan symbology, I've set up some standard symbologies here for plan. For example, when areas are created, they're going to be on a certain level, weight, and color. Same with pipes and inlets and so forth. So everything has a specific plan symbology as I draw it. Updates, I'm going to set some automatic updating, so once I have my system designed, I can go back and have things kind of automatically change as I make edits to a particular invert of a pipe or a particular location of a inlet. Things will automatically update and recompute. And then save options, I've set it to automatically save my drainage updates. So those are the project preferences. We can further review them later, but at this point we're just click OK, and we can then take a look at the drainage library.